Dungeness crab are an iconic species here. They are the single most valuable fishery on the West Coast. So Dungeness crab are surpass salmon, all other species as far as the total value of the fishery. So they're iconic. There's a large commercial fishing fleet here. There's a large recreational contingent of folks who love to go out and catch Dungeness crab. So from a fisheries perspective, it's highly valuable. They're very productive animals, and so and how we manage them, they are managed very sustainably. So it is a highly valued and sustainable thing for folks to eat. So we've been monitoring the population since the late 80s, so we consistently do test fishing around the Sound. So that involves dropping a number of pots in an area, and then based off of what we see from previous years and what we catch that year, we can use that to inform how many crab are in the area. Most folks are familiar with climate change, where burning of fossil fuels and other greenhouse gases that are emitted through land use changes and whatnot, those are going to the atmosphere and they are trapping infrared radiation and leading to greenhouse warming. And so that same anthropogenic CO2 dissolves into the surface waters of the ocean. The very most common thing that folks look to is that it lowers the pH. But some of the other things that are more important are changes to the seawater chemistry. And so marine organisms that calcify use carbonate ions along with calcium to form their shells. And because of ocean acidification, there's some changes in that carbonate chemistry, and so those carbonate ions that those organisms use to build their shell, there's actually fewer of them as you dissolve CO2 into the surface waters of the ocean. So most organisms that calcify, it becomes more difficult for them to build their shells because there's fewer of these carbonate ions, as well as this lower pH. We manage these populations using what we call 3S management, which utilizes sex. So we only allow folks to harvest males, and so we don't harvest females. And then we have size, so we have a minimum, size that we allow folks to target. So we're protecting juveniles or subadults there, but we also have seasons. So we're making sure that we're not targeting targeting crab when they're molting, for example, when they're vulnerable to mortality due to handling and stuff like that. Because of this 3S management, we have a really sustainable fishery. However, if juveniles, for example, were impacted greatly throughout the Sound, that could be a huge bottleneck for these populations. So our management is set up on all of these organisms reproducing successfully and their juveniles getting to these areas and settling out and contributing to the fishery in years to come. If we have recruitment failures, which is what could occur, we have not seen that we've not been able to determine that that's occurred because of ocean acidification. But if we had recruitment failure, we can do everything we can to manage the adults sustainably, but if we don't have consistent recruitment, the adults won't be there for us to manage. So it is something we are actively thinking about and needing to consider in the future. It's not something at this point in time that drives our management. There are a good number of folks really plugged into research around here. We are focused on kind of monitoring the populations. We have collaborations with folks. There's a group called the Pacific Northwest Crab Research Group that the state, other state agencies, as well as I think almost every single treaty tribe in the area is plugged into. And one of the key projects they're doing now is to get a better understanding of where those juveniles are and how the whole Puget Sound is interconnected and where the populations are and where those juveniles are going. Once we have a better understanding of that, we can start to even just go down this route of, okay, now that we have a better understanding of where these juveniles are in time and place, what are the potential impacts to these juveniles now? One other thing I guess makes sense to touch on is Puget Sound and the coast we're uniquely impacted by ocean acidification relative to what you might hear of statistics for like the global ocean. So off the coast we have upwelling. And upwelling is a process where during the summer we have northerly winds that flow south, and there's when that air moves south, it forces the surface waters offshore, and cold, nutrient-rich water upwells from the deep to replace that water. And why that's important is those waters are naturally high in CO2, low in pH, and they also have high nutrients. Those waters are really crucial for the productivity of our waters because they upwell nutrients. However, them being low in CO2 do pose some challenges for organisms if they're in those conditions. And when you overlay human-caused ocean acidification on top of the normal signal that we see from upwelling, you'd get organisms could experience conditions that they wouldn't normally see in kind of a stable global ocean kind of situation. And so in Puget Sound, we also have a lot of freshwater input. That lower salinity water has lower what we would call buffering capacity, and so you can actually see greater changes just because of the natural influx of fresh water into Puget Sound. So because of those two processes, we have what we think is a situation where we might have greater impacts than looking at like an open ocean, for example. Some of the most recent research on Dungeness crab juveniles that was done off the coast just a couple of years ago showed that the crab that were in these upwelling conditions that were truly kind of corrosive for them, that actually started to degrade their shell to some degree. That was one of the first times that researchers were able to show that crab coming from conditions in the water are having impacts due to low pH. Most of the time of the studies that we read that folks are doing in the area, it's much easier to bring organisms in the lab to control what's going on, so you can really test for one specific factor, like ocean acidification. But as you would guess, ocean acidification is just one of the factors or stressors that these organisms may experience. So other things that come along with ocean acidification are low dissolved oxygen oftentimes. And so as most folks are aware, these organisms need oxygen to breathe as well through their gills. And there are areas in the Puget Sound that are naturally, Hood Canal being one of them, have natural occurrences of low dissolved oxygen. And so it's important to point out that OA is one stressor, but these organisms usually have multiple stressors they're dealing with. And ocean acidification, low dissolved oxygen. The other thing that's really timely is temperature. So these crab, or Dungeness crab, their adults, are completely subtidal. They're not coming out. But juveniles stay in estuarine conditions near shore areas where they have more protection from algae and others. Also, adult crabs can actually be cannibalistic on juveniles, so they like to kind of separate themselves. And so juveniles are in these near-shore conditions that are in algae, that kind of thing, where they're more protected. But that is also a situation where they could experience temperature changes as well. And this last year we saw, not necessarily impacting Dungeness crab as much, we didn't see that at all, but we had a heat wave in late June, early July, and we saw intertidal areas where we had very low tides that corresponded with these really high temperatures, as most folks were aware. We had bivalves on particular beaches that faced, westerly, that were essentially cooked in their shell due to those high temperatures. Didn't impact crab, but temperature is something with climate change that we know is impacting species high and low within the marine food web. And so temperature, along with dissolved oxygen, along with ocean acidification, these are three stressors that would largely not happen by themselves. They're like going to happen synergistically. And so we kind of have to keep our eye on the whole host of stressors that crab would be facing, not just OA. And they, when researchers look at multiple factors, it usually has a greater impact or different impacts than what we see if we're compared to looking at OA alone, if that makes sense.